Hey guys, Mr. Middleton here. Today we're going to introduce inequalities, start our second unit. At the end of this lesson, you should be able to determine whether a given number is a solution to inequality, and you should be able to find and show all solutions to inequality. Alright, let's start by solving an equation. 3x minus 4 equals 11. We'll solve this equation, and when we do, we will add 4 to both sides. 3x equals 15, divide by 3, and x will equal 5. Okay, notice when finding a solution, we're looking for any number that makes the equation true. When we plug 5 back in, excuse me, the left side will equal the right side. So the solution above is 5. Because 3 times 5 minus 4 equals 11. 15 minus 4 equals 11. The left side will equal the right side. But what about inequalities? The prefix in means not. So therefore inequalities means not equal. Or not equalities. Excuse me. This sign, you read it as greater than, reading from left to right. This sign is less than. When we have the line underneath it that adds or equal to. So greater than or equal to. Less than or equal to. And this last one just means not equal to. As we go through the unit, you'll be more familiar with those terms. Make sure that you take some time to reason that in your own head so that you can speak math as well. So if a solution to an equation is any number that makes the equation true, a solution to an inequality is any number that makes the inequality true as well. The difference is that with their equation there's one solution, and with an inequality there are infinitely many solutions. Means a lot. So here, of the numbers listed, circle the ones that are solutions to the inequality. Like we said, there are a lot of them. These are just, some of these are solutions, some of them won't be, but there are a lot more numbers than what we'll circle. So here we have n is greater than or equal to 9. So we're just going to plug our number in and see, does it make the inequality true? 6 is not greater than or equal to 9. 13 is greater than 9. Negative 25 is not. 9 is not greater than, but it is equal to. So B and D. For number 2, we have 6 is greater than H. 6 is greater than 2. That's true. 6 is greater than negative 18. That's true. 6 is greater than 15. That's true. Or sorry, that's false. I'm a math teacher. And the last one, 6 is greater than 6. That is false. 6 is not greater than 6. Make sure you pay attention to those signs with those numbers. Alright, and then the last one, a little bit more we have to plug in and see what happens when we plug in our value. Negative 9 squared is 81. 81 plus 3 is 84. 84 is less than 28? No. 3 squared, 9 plus 3 is 12. 12 is less than or equal to 28. That's true, so 3 works. Negative 5 squared is 25. Plus 3 is 28. 28 is less than or equal to 28. True. 6 squared is 36. 36 plus 3 is 39. That is not less than 28. Okay. So that's us just plugging it in, seeing if our inequalities work. Notice that we show at least 2 solutions for these problems, but there are infinitely many. And so, since inequalities have infinitely many solutions, it's impossible to list them all out. We'll need to show a way to show all these solutions. And the only way to do that is to use a graph or number line. Let's do that. I'll say graph here because my instructions will usually tell you to graph it. You have to shade one side of the number line that represents all the solutions. So here we have x is greater than 7. I'm going to graph this to show all the solutions. Your number line can be very simple. I usually just highlight the number that's the boundary. Okay, and the boundary is shown here. All right, x is greater than 7. I'm going to leave an open circle and go to the right. If I have m is less than or equal to 1, 1's my number, I'm going to have a closed circle and go to the left. Okay, now the reason we use an open circle, we'll use an open circle when the signs are greater than or less than. The open circle denotes that 7 is the boundary, but it's not included in the solution. Like we can get as close to 7 as possible without including 7. We use the closed circle when our boundary is a part of our solution. And it is a part of our solutions when it can be equal to as well. So when it's or equal to, it's a closed circle. When it's greater than or less than, it's not or equal to, then it's an open circle. And then we just shade to this part of the line that makes it true. So one tip is to have 0 on your number line. And then ask yourself, does 0 make this true? If the answer is no, like 0 is not greater than 7, then shade away from 0. If the answer is yes, like 0 is less than 1, so shade towards 0. Okay. All right, so we're going to graph these and show the solutions to each inequality. So I have my boundary, -4. This is less than, so I know it's going to be an open circle because it's not or equal to. And then I'm going to say, okay, 0 is here. Okay, p is less than -4. Is 0 less than -4? Nope, shading away from it. Okay. All right, 82 is my boundary. It's or equal to, so I'm going to have a closed circle. 82 is greater than b. So can b be 0? 82 is greater than 0. That's true. So I'm going to shade towards 0. Okay. -5. This is less than. It's an open circle. 0 will be here. -5 is less than 0. Is that true? Yeah. So shading towards 0. All right. Now, that's the math of it. There are going to be some situations where we have to put some applications to the real world. And when we do that, we're going to make sure that we focus not only on the number, that's usually our limit, but we're also going to focus on what our inequality should be. There are some key words that we'll use, and we'll see a couple examples in these first two. All right, so we're going to write an inequality and define our variable as necessary. So to do well on a test, you should spend at least 45 minutes studying. Here's a key word for us, at least. You always think, can I do just this amount? Do I want more or less? Okay, you always think about it with allowance. If you ask your mom, hey mom, can I have at least $5? Are you going to be okay with having $5? Yeah, because you asked for it. If you said, mom, can I have more than $5? Are you going to be okay with $5? No, because $5 is not more than $5. So, I'm going to put T for time that we spend on the test. And T and 45, how does that compare? T has to be at least 45. So we ask, can it be 46? Yeah. So T can be greater than 45. Can it be 45? Yeah. Or equal to. The car can go at most 120 miles an hour. Say car, 120. can the car go 121 miles? No, it says at most, so we know that C is less than 120. Can it go 120? Yeah, it says at most it can go 120, so it can be equal to it. Number 3 and 4, we're just given a graph, and so we're going to use that graph, see the type of circle, is it open or closed, see the direction of the arrow, and make our inequality from that. So I'm just going to say n -1 for this situation. It's a closed circle, so I know there's going to be an or equal to, and the arrow's going to the left. So n is less than or equal to -1. For 4, I see my circle's at -3. Okay, and so now this says -3, so x is greater than -3. There's no line underneath because the circle's open, showing that -3 is not a part of our answer. Okay, so some takeaways here. When you plug in your number, it will make the inequality true. There are a lot more solutions than one, infinitely many solutions in most cases, and actually in every case. When you have or equal to, you shade in your circle. When you don't, the circle's open, and then you should shade your number line to the direction of the numbers. That will show us that it continues forever in that direction. Okay? All right. See ya.